The sun, a giant ball of burning gas, is the reason we're alive. The sun provides light, warmth and energy to our entire solar system. Without it, Earth would be a frozen, lifeless rock. But the sun isn't going to last forever. Like everything else in the universe, the sun has a lifespan. It's born, it lives, and eventually, it dies. Right now, our sun is in its main sequence phase, happily burning hydrogen into helium in its core. This process is what gives the sun its energy and light. Stars form from massive clouds of gas and dust known as nebulae. These nebulae are the birthplaces of stars, containing all the essential elements needed for star formation. Gravity pulls these particles together, causing them to clump and form denser regions within the cloud. Over time, these regions grow larger and more massive. The cloud collapses under its own weight, leading to the formation of a protostar at its core. This process can take millions of years. Temperatures and pressures rise at the center, reaching extreme levels. This intense heat and pressure are crucial for the next stage of star formation. Eventually, it gets so hot and dense that nuclear fusion begins. A star is born. This fusion process converts hydrogen into helium, releasing vast amounts of energy. Our sun formed this way about 4.6 billion years ago, emerging from a similar cloud of gas and dust in our galaxy. It's been shining brightly ever since, providing the energy necessary for life on Earth and driving the climate and weather systems. But the sun's fuel, hydrogen, isn't infinite. Over billions of years, it has been steadily consuming its hydrogen reserves. In about 5 billion years, the sun will run out of hydrogen in its core, marking the end of its main sequence phase. This is when things start to change dramatically. The sun will expand into a red giant, engulfing the inner planets, including possibly Earth. When the hydrogen in the sun's core runs out, the core will start to shrink. This shrinking causes the core to heat up even more. The outer layers of the sun will expand outward, growing much larger. The sun will become a red giant. As a red giant, the sun will be enormous. It will engulf Mercury and Venus, possibly even Earth. The sun's outer layers will be much cooler than they are now, giving it a reddish appearance, hence the name red giant. Section 4. Inside the red giant. Inside the red giant, the sun's core will be a busy place. The core, which was once a stable environment, will become a cauldron of intense activity. The intense heat and pressure will allow the sun to start fusing helium into heavier elements, a process that is both fascinating and crucial for the evolution of the star, like carbon and oxygen. These elements are the building blocks for many of the materials that make up planets and even life itself. This process will release even more energy, creating a spectacular burst that will radiate outward, further fueling the expansion of the sun's outer layers. The outer layers will swell dramatically, making the sun much larger than it is today. This helium-burning phase won't last forever either. It's a temporary but critical stage in the life of the star. Eventually, the sun will have fused as much helium as it can. The core will start to run out of fuel, leading to a decline in its activity. The core will contract again, becoming denser and hotter, but this time it won't be able to ignite further fusion. The core will become a dense, inert remnant. The sun's time as a red giant will come to an end. It will cool and shrink, transitioning into the next phase of its stellar evolution. Section 5. The fate of our solar system. After the red giant phase, the sun will shed its outer layers into space. This process will be both spectacular and violent as the sun expels vast amounts of material into the surrounding cosmos. The outer layers, rich in elements forged in the heart of the sun, will be cast off, creating a stunning display of cosmic fireworks. These layers will form a beautiful glowing cloud of gas and dust called a planetary nebula. This nebula will be illuminated by the remaining core of the sun, creating a breathtaking sight visible across vast distances in space. The colors and patterns of the nebula will be a testament to the complex processes that occurred within the sun during its lifetime. At the center of this nebula will remain the sun's core, a small, dense object called a white dwarf. This white dwarf will be incredibly hot and dense, composed mostly of carbon and oxygen. It will be a remnant of the sun's former glory, a stark reminder of the star that once was. The white dwarf will slowly cool over billions of years, eventually fading away into a cold, dark cinder. This cooling process will take an unimaginably long time, as the white dwarf radiates away its remaining heat. Over time, it will become a black dwarf, a theoretical object that has yet to be observed in the universe. The solar system as we know it will be gone. The planets, moons, and other objects that once orbited the sun will be scattered or destroyed, leaving behind a dark and empty space. The remnants of our solar system will drift through the galaxy, a silent testament to the passage of time. But even in death, the sun will have played a vital role in the universe. The elements it created and dispersed will contribute to the formation of new celestial bodies. The death of the sun will be a part of the larger cycle of stellar evolution, a process that has been ongoing for billions of years. The material it ejects into space will eventually become part of new stars and planets, continuing the cycle of cosmic evolution. This cycle ensures that the universe remains dynamic and ever-changing, with new stars and planets forming from the remnants of those that came before. The fate of our solar system is a reminder of the transient nature of all things in the cosmos.